So yeah, write each of the
Okay.
following as products of linear functions, then state the zeros.
Okay. So these come in conjugate pairs. 6 plus 3i is the other one. Um, and if they both work, which they should, they're giving it to you, it'll then be some sort of a quadratic that you can solve, with factoring or quadratic forming complete the square. But it's pretty messy here. You want to leave plenty of room for this when you're working it out. And there'll be quite a bit of side work on this. So um, it's the same thing we've been doing. It's just you got to be really careful with all your coefficients. So this is 12 minus 6i. So when you add vertically, it's minus 9 minus 6i. And this is where you've got to be able to FOIL these. 6 minus 3i times minus 9 minus 6i. What's your comfort level with foiling something like that?
Pretty good. Let me try to follow it.
Why don't you try this one? I've got the answer up. This is really the key to being able to do well in this part of the course. Um,
Um, all right, I got minus 72 or negative 72 minus 63i.
so I've got minus 9i. That's why this is so important. Let's take a look here. So it should be minus 54 minus 36i minus 27i. No, pause plus 27i. That's the issue.
Yeah, that's
Um,
what I got wrong. Yeah.
okay, that's let you talk me in. And then minus 18i squared. So it ends up being minus 72 minus 9i. Okay, and it's so easy to make these mistakes here. So this becomes minus 23 minus 9i. And then again, you have to FOIL 6 minus 3i times minus 23 minus 9i. Go ahead and give that a try, please. I'm using software to check. That way we don't have any issues. Um,
All right.
but yeah, give that a try. Let me know what you come with. I'll step away for 30 seconds. Be right back. All right, I am back. I mean, the numbers are a little bit larger here.
So I got minus or negative 165 plus 15i.
That is correct. And it's good to get into the habit. Um, it's good to get, I was gonna say here, the numbers should be getting larger just to make this work, but just you might want to always write it in this A plus BI form. So 30 plus 15i. And so you got to again do it one more time here. 6 minus 3i times 30 plus 15i. So go ahead and FOIL this one for us, please.
I got 225.
Yeah, and that is what we expect to get because that gives you 0 at the end. All right, so the good news is the second one is usually easier, the conjugate pair 6 plus 3i, but you do have to bring down all of these that you worked out, so they have to all be correct as well, which could be a problem. And then you gotta, rinse and repeat here. You don't need the 0, but so the two comes down and that becomes 12 plus 6i. And so you'll notice this pattern of the i's canceling because there's not supposed to be any i's left over. And then you've got 18 plus 9i. So again, the i's cancel. And then here you get minus 30 minus 15i. And there you have it, 2x squared plus 3x minus 5 equals 0. And then you have some options here. You can try factoring. That's usually the preferred option.
All right, so then you would,
So go ahead and try factoring this for us. It does work out.
would it be x minus 3 of x plus 7?
Gotta be a 2x and an x for sure. It ends up being plus 5 minus 1. So if that's unclear, the way to proceed is you multiply the 2 and the minus 5. And then you find two factors of minus 10 that get you to positive 3. So that's 5 and negative 2. And then you split apart the 2x squared. As you know, it becomes minus 2x plus 5x minus 5. And that's when you can factor out the 2x from both. And then put the plus 5 there. And you can see that you get back to this. Is that okay?
Yeah,
Great. All right. So what we're down to is, I think you said writing the linear pairs.
yeah.
So we have 2x plus 5, x minus 1, but then we've got those two from the original here, 6 minus 3i and 6 plus 3i. So it's x minus 6 minus 3i, x minus 6 plus 3i. And then it depends how your teacher wants you to proceed. Like sometimes you can distribute the negative inside here. I actually prefer to see students FOIL this because then there's no i's in your polynomial. I don't really know what your teacher wants, so that's where I'm, asking you.
Mm, um, All right, so those would be the linear.
I mean, that's it. I mean, I don't know how your teacher wants you to present the answer. Is that okay?
Yeah,
All right. Like you can see, they're kind of long problems, right? And there's lots of places to go wrong. Do you want us to work on that other one now as well? G3?
yeah.
Great. Let me go ahead and grab a snip of it. Right. So again, those roots come in conjugate paired, so it's also 1 minus 3i. I guess the small point is it might have been better to do the original one as 6 plus 3i instead of 6 minus 3i. That might have been slightly easier inside here. I don't know. I mean, I'm just throwing that out there as an idea. So we'll do 1 plus 3i. Then you got a 1, a 4, a negative 2, and a 60. So when you try to keep it in that a plus bi form, so 5 plus 3i, and then you've got to multiply 1 plus 3i times 5 plus 3i. So will you FOIL that for us, please, and let me know what you come up with?
All right. I got -4 plus 18i.
That's correct. That becomes -6 plus 18i. So you got to do one more foiling, 1 plus 3i times -6 plus 18i. And you should get -60 when you're all done. Should being, big if, but go ahead and give that a try, please.
Plus 3i. I got -60.
Yes, and that's what we expect. That's perfect. All right, so now we got to do the same thing. It's 1 minus 3i, and then we got to bring these down. So this 1 comes down, this becomes 1 minus 3i. And what you should notice is that the i's go away each time. 6 minus 18i, which becomes 0. And so you're down to x plus 6. X plus 6. And then you've got those other roots to deal with, 1 minus 3i and 1 plus 3i. So we have x minus 1 minus 3i. And then x minus 1 plus 3i. And then x plus 6.
Got it. Then you just leave it like that since it's asking for linear factors, not.
Yeah, it's like, I mean, because this stuff does you know multiply out and the i's cancel, but I guess they don't want that.
Yeah. All right.
All right, so you got some other stuff for us to look at tonight?
Yeah. We go over this. So it's in the chat now.
All right, got it. So it looks like more of the same, right? Looks like, so this is maybe slightly easier because it's 5i and then minus 5i are the roots. Um, these aren't as bad because the it's not foiling every time, but still easy to make some mistakes here. Um, the other thing is that you can't combine anything, so it becomes minus 3 plus 5i, and then you're multiplying uh this minus 3 plus 5i times the 5i. You just got to be careful. I would try to stick with writing everything in a plus bi form. So could you multiply 5i times minus 3 plus 5i for us and give it to me in that a plus bi form?
Anyway. I got negative 25 minus 15i.
That is correct. All right, so this becomes minus 4 minus 15i. So you again have to do that, multiplication 5i times minus 4 minus 15i.
I got 75 minus 20i.
That is correct. So that becomes just minus 20i. The last one becomes 100, which is 0. All right, so let's do it now for minus 5i. So this time you got to bring the coefficients down. Like if you didn't do all this work, you could just grab it and do it right there. You don't have to rewrite it like I'm doing. That'll save you a little time on the test. Um, but go ahead and work this out. You should find that you get 0 at the end. get something like this.
Um, oh wait, I think I realized where my mistake was for the question. Did not get that. Also 20. Yeah, now I got the right answer. Yeah.
Okay, fantastic. So see if you can factor this last one here.
I got x minus 4 and x plus 1.
Good. So then the other ones here are x minus 5i and x plus 5i.
Oh yeah, because of the factoring. Yeah.
All right. Any questions on that?
No. Okay, so whenever it's x equals like 5i, for example, you have to do both 5i and negative 5i.
Yes, exactly. And the same thing applies to like square root of 3. Like sometimes you'll see this on a test or quiz. They come in pairs, but for you, it's like, 2i
Because
goes
square roots
minus 2.
also come in pairs.
Exactly. 5 minus 6i, 5 plus 6i. It's always the operator that changes.
Got it.
Otherwise, you can't do any of these problems. You don't have enough information to find the roots.
Got it. Let me pull up the next question. Um, last one, let's do this one at 4 point, and then we'll go to 4.9.
Okay, there it is. Okay. Yeah, so this, I mean, this is it looks really odd, but the other root is minus I squared of 11. So this is horribly messy. Mm, but but this one actually, and I don't know if this was intended, but this one you actually can factor out an x squared plus 11, and then it does actually work out this way. So you can actually put an 8 here.
Uh, the- yeah, so I would
So
put,
this becomes x cubed plus 8 times x squared plus 11, and that's where those two roots come from. The I root 11 and minus I root 11, they come from setting the x squared plus 11 equal to 0.
and then for x cubed plus 8, you can do x plus 8 and then x squared
You
minus
can
8x.
you can break this one into x plus 2, x squared minus 4x, sorry, minus 2x plus 4. And that does not factor, even though it kind of looks like it should. Um,
Wait, wouldn't it factor?
it's different. It's sum of cubes.
But the x squared minus 2x plus 4 part of it?
This is always quadratic formula. So this one we need to we do need to use quadratic formula on this because it probably says to put that down into linear factors. Is that right?
Mhm.
That is that okay? That's what I was going to do next year.
Yeah.
So it's 2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Which is it's a square root of negative 12 all over 2. So it's 2 plus or minus 2i square root of 3, both divided by 2. You can see it just gets really messy. You got the x plus 2. You got 1 plus or minus I square root of 3. So you got x minus 1 plus I square root 3. X minus 1 minus I squared 3. And then you've got the 2 that you started with from the beginning.
The x equals plus.
Yeah, so it's x minus I squared 11, x plus I squared 11. I guess that's how your teacher wants you to present your answer.
Yeah. All right.
What else you got?
All right. Let me put that on 4.9. Here it is. All right. In 4.9, I kind of just want to do some practice. So let me here quickly download this to the chat. All right, there we go. Okay, upload this here.
I don't see
All
anything
right,
yet.
let
Oh,
me open it. Here we go. Now it's sent.
there it is.
So yeah, just got to go over some problems and then maybe some more problems like we made up, like almost like those problems.
Okay. So do you want me to pick some or do you have some here you want us to do? Maybe we did
You
some of
can
these
pick,
already.
you can maybe make some based off of them, like make
Oh, I
some
can, I can,
questions.
I can find, yeah, I can find these. Okay. Okay. Right. I gotta just find some that are reasonable here. Um, okay. So for this one, I want you to write out all the possible roots for me. That's that P, or that's P, and then that's Q. So you got to do P over Q. So go ahead and give that a try. Karthik, so I just wanted you to list the zeros. You don't have to actually find them yet, but did you
Uh,
get this
um,
list?
yeah.
Okay. Now, just because I think you might see this on a test, I want you to try 1/3 for your root, um,
All right.
which does work. So I wouldn't, want to give you one that didn't, but you will maybe see one like that on your test. So, quiz, whatever. So try that one for me, please.
Yeah, because I was trying the 3 and the 1 before, and
Yeah, no,
those
and
both.
those there is ones there that do work. Right. I just wanted you to list them just to get some practice, but go ahead and try this one. It should work.
Yeah, it works out.
Right. And then from here, you can write 3x squared plus 12x plus 9, and you could factor a 3 out of each. So it'd be x squared plus 4x plus 3. Okay. And so could you try factoring this for us, please?
All right, I got 3 and then x plus 1 and x plus 1 and x plus 3.
Right. So one little thing here on writing roots, or let's say I tell you that the roots are like 1/3, -1/4, and 2/5. Okay. Here's how you write them. You would write them as 3x minus 1, 4x plus 1, and 5x minus 2. So what you don't do, and I don't know if your teacher covered this, you do not write x minus 1/3, you don't write x plus 1/4, and you don't write x minus 2/5. It has to be in this form here.
The x goes first, followed by the comma.
So
So
if you
x,
wonder how I got that, it's essentially solving this manipulating this equation, like x equals 1/3. If you multiply both sides by 3, that gets you the 3x equals 1. Subtract 1 from both sides, and that gets you to the 3x minus 1. X
and then you
equals
do that for
minus
all
one
three of
fourth.
them, yeah.
Yeah, you multiply by 4. 4x equals -1. Add 1 to both sides, and you get 4x plus 1 equals 0, and so on. All right, we do have to stop here for